Good morning from cold Vancouver, 7 o'clock in the morning in Vancouver, and good morning to the rest of the North America and South America. Good afternoon, Europe, and we watched also all the way to Israel, Saudi Arabia, and India. So it's a late evening for John Chapman, who is our speaker tonight. Good evening, John.
Good evening, everybody, or good morning, as the
Thank
case
you for
may
staying
be.
late, and thank you for yesterday getting up early. I stay late, so we cover Australia and Asia that usually we skip. So we wanted to do 2 times this time, because it's the first of the series of 10 lectures of Advanced Diamond Academy. This one, John, was very nice to we do it for free for everybody. It's an introductory seminar, review of principles for advanced gemological equipment. Don't expect we'll talk about all spectral lines and defects. We'll talk about this later, but we'll explain, John, actually Chapman, physicist, how this instrument works. So let's start with a little review. I will introduce John more formally later. So as you know, with Dusan Simic, my colleague, we wrote a book 6 months ago, or published it in October, and we did 10 webinars in 5 months, what is a great achievement, I think. And we brought you the experts from all part of the trade, for people who are growing diamonds and know how to do this, like Malay Hirani from India, Boris Fegleson from USA, CVD and HPHT, to manufacturers like Argodanza from Switzerland, or people who are wholesaling and selling these diamonds, like Tom Chatham from Chatham Created Diamonds, to people who are like me, gemologist, Sherry Hand from GKL, myself, Dusan. We talk about how to identify, how to look at the inclusions, fluorescence, cross-polarized filters. We touch on advanced instruments, of course. And we also organized last 2 trade-oriented. We want to include also people from the trade, like journalists like Albert Robinson from New Jewelry Magazine. He was a moderator, webinar 9. Rob Bates, Don Scott, Lab Grown Diamond Magazine, Mark Kulinan, Tanya Nizgretsky, who is selling online. And the last one was very, very special, from CVD factory to the market, because we open our webinar. We went to the factory in New Jersey. We went to the diamond cutting factory in India. We went to a dealer from India, Shreyan Shah, who is selling these diamonds. So all these could be watched on our YouTube channel, Branko Gems and G&J, and I encourage you to watch them. All 9 webinars except one on memorial diamonds that is not public. So people who help us for this book, beside Boris Fegleson, Sherry Woodring, Malay Harani, and Frank Ripka, who wrote chapters from 5 to 25 pages, believe it or not, are also people who review the book. Antoinette Matlin's best-selling gem author was nice to read, together with Richard Drucker and Stuart Robertson from Guide Magazine. They wrote a nice review in their online or in their Guide Magazine. And Alberto Scarani, our friend from Magi Labs, will touch some of the instruments he is using in today's lecture, but he was reviewing the book. And dealers Nilesh Shesh from Nice Diamond, Tom Chatham, gave us these nice samples on the left for a cover of the book or to study. And we designed book in India. Godwin and Mumtaz Gonzalez and Nesha Popovic, our countryman, was promoting this book and responsible for these newsletters, collecting your names. We couldn't do it without gold, silver, and other sponsors, distributors. We pre-sold 500, 600 books before we even printed. I want to thank to Kim Hughes from NCJV Australia. Yesterday, we had a lot of people from Australia watching us. And Gail Brett Levin from NGA USA, for be kind of trusting in me and Dusan to order book in advance, as well as Shirley Mitchell from JVA from England. They're distributors in Australia, England, and they're selling in America. We sell directly, brancogem.com, shop at books. So this is the book. Probably most of you got it. If you didn't, encourage you to get it, because it's for intermediate level, basic to intermediate. We want every jeweler, every gemologist, every appraiser, wholesaler, retailer to have this book. That's why we didn't want to make it too heavy with the science. We want really people to know how to use loupe microscope, cross-polarized filters, fluorescence, light, UV light, either regular or one that John Chapman is making, like a PL and jewelry inspector. And we touched on advanced, but we focused on intermediate level or classic instruments. Why? Because we wanted to leave something for the future. And this is complementary book. We plan it together, but we want to leave science and advanced for the next book that we wrote 80%. Yes, John? Because John is editor of the book and he reviewing it with me. And we have technical reviewers, Dusan Simic and Miko Astrom. I'm very, very happy to have some very famous names like Dr. Alan Collins from King's College. He's retired now, but when I started to work in GA in 95, the first articles they gave me to read about diamonds when I was in German Dental Research Department was Alan Collins. Same with Dr. Zaitsev. He's a professor at University of New York. He wrote for us Bible on spectroscopy, Industrial Book of Diamonds with explanation of all spectra. We had Dr. Tajin Lu from NGTC, biggest lab in China, who talk about Chinese synthetic diamonds updates. They're making doublets now in China and in Asia. Of course, Thomas Henschwager, our friend, he's the only one speaker that I invite 2 times to my Mediterranean German Jewelry Conference that John is editor. He has talked about diamond spectroscopy, fluorescence imaging, a lot of spectroscopy that's been in June. And Dr. Victor Vins from Russia, we talk about diamond treatments, modern color enhancement technology, and I will cover new producers from Europe, India, Israel, Russia, USA. I will cover portable instruments in next lecture, what is April 8th, and I will cover case study, like I'll show you with Dusan diamond by diamond what we can do with advanced instruments and classic instruments. This is all upcoming in April to June. I will tell more after John's presentation. John is our featured speaker. And I know John for 20 years. We met first time in Perth in 2001, John, yes? And I was visiting Rio Tinto Argyle mine, and he was a technical advisor over 30 years there. He gave me a nice tour of the company, and 2014 he gave me a tour of the Argyle mine. Actually, it was really exciting. I was studying pink diamonds a lot last few years, and John also knows about pink diamonds. In his Delta Diamond Lab, he basically also doing a provenance origin of pink diamonds. And he's also editor of Mediterranean German Jewelry Conference and making instruments, as you know. And he's my editor of the book. So John, I will now give you the microphone and make you the host because we want to see your video that you prepared for us. About advanced instruments and what we can do with them. So please show us your approximately half an hour video, and during that time, please in Q&A button on the bottom, there is a chance for you to ask questions. Please don't be shy. We have a lot of good participants today, and please ask questions, and John will answer just after his presentation. Okay. I will stop to share and give a chance John to share his video.
Right, over to me. Yes, I've cheated rather by preparing a video, but at least that way you get a bit of music and a few daylight scenes. So over to the video, and here we have it. Hopefully you can hear it. Advanced text on diamonds will often produce spectra like this, like this, or perhaps that, or even that. And if you're not in an advanced lab, you might wonder how they're obtained and what they mean. In this webinar, I hope to throw some light on the more advanced methods and technologies used to determine the origin of a diamond. Hi, I'm John Chapman, living in Perth in Western Australia. At this time of year, a nice sunny place, so here's some images for those who are in the Northern Hemisphere battling with the rather nippy conditions there. Let's just see how the temperature is today. Got one of these big garden thermometers. Oh look, it appears to be a dead spider. Oh, we have 36. How about that? Oh, look. Analysis of diamond is basically an exercise in trying to detect defects. These defects being responsible for colours and giving some information about the origin of the stone. Now, a defect can do two things. It can absorb light and it can emit light under certain circumstances. And this can happen across the broad spectrum from the short ultraviolet down at say 200 nanometers all the way up into the infrared, almost at 10 microns. And this is what instruments are designed to do, is to detect either those emissions or absorptions that are characteristic of the defects of interest. Anyway, I've been playing around with diamonds for a few decades, then more recently I've been building instruments. These instruments can help gemologists distinguish natural from synthetic and treated diamonds. I realise in the title of this webinar there's the word advanced, but I'm going to start with an instrument that's not so advanced. Firstly, a few words about terminology. Photoluminescence is abbreviated to PL and refers to the phenomenon of fluorescence and phosphorescence. PL is stimulated by light that is normally in the UV region because the eye can't see it, only the luminescence. But the exciting source can be beyond UV into X-rays, but few researchers use those, and few use electrons that can also excite light and provide useful information. Most of us are familiar with UV fluorescence, but I'd like to mention a few aspects that may be of interest. Firstly, the light source. These have traditionally been mercury vapor lamps with appropriate filtering to provide LW and SW. Nowadays, LEDs are available. These are certainly suited for LW at 365 nanometers. But the spectral spread of the LED extends into the low 400 nanometers and so is a bit visible. So filters are still necessary. Here we have what is known as a Woods filter, blocking out the visible. Ah, I hear you say, but I can still see it. Well, actually, I can't, and nor would you if you're in my seat. You see, the phone camera can detect the UV and tends to show it as purple. So from an instrument perspective, a second filter is needed to prevent any UV reaching the camera, as this is often used to view and record fluorescence. The same applies to SW. LEDs are available at 255 nanometers, but they are pretty pricey. So in the interest of economy, I still use mercury vapor lamps. A problem with them is that the intensity steadily increases as the lamp warms up over a few minutes. Anyway, armed with a shortwave and longwave viewing system, one can examine the reactions of a diamond, and although one can see colour, the colour of a reaction, the eye is unable to detect the composition of the colour. For that we need to split the colour into a spectrum in which one can detect features that may be only a few nanometers wide. Prisms are an early and common method for spreading light, light that may be either emitting light in the case of fluorescence or transmitted light in the case of general viewing under white light. A spectroscope is a low-cost instrument that can be used and used to great effect in the right hands. There are a few shortcomings with spectroscopes, besides the fact I'm not very good at using them, but they're limited to the visible spectral range and there's no quantitative information about the wavelengths of any features that I've observed. This is where a spectrometer, or if you're trying to impress a client or your boss, a spectrophotometer comes into play. Diffraction gratings are the heart of any modern spectrometer. Let me describe the design of most compact modern spectrometers, because I think it's really quite neat. What you have is a slit and with light that passes through it. Oh, do you like this pen I got? I got it for Christmas. Rather neat. Anyway, and the light passes through an optical element which collimates the light, and then it goes through a grating of which you've got two different colors going off at different angles, and they strike, no they don't, they go through a element that focuses the light onto an array, a sensor array. If the diffraction grating is of a reflective nature and the other various elements for focusing and collimating are also made into reflective curved elements, then it's possible to optically fold the system into a more compact arrangement. Let me show how it looks in real life rather than with bits of paper. Here's one of the smaller compact units that are on the market. See, it says removal voids warranty. Oh well, the sacrifices I make for the benefit of a webinar. So if I take that off and give me access to screws, so I can undo the top of it and remove the circuit board, and inside we have a slit at one side here that opposite a curved reflector which then collimates the beam onto the diffraction grating. That diffraction grating, a reflective one, which then sends the various colors to another curved mirror which effectively then focuses the beam onto the sensor, which is a line. So there we have a sensor, and it provides a signal to go to a computer. These can come in bigger sizes for greater sensitivity, either in resolution or just simply sensitivity. And the light, in order to get the light into it, it can either happen with the aid of an optical fiber, which some systems use for versatility, or in the instance of the Spectrum, the light is focused directly onto the slit. And for the light, there's two modes. There's a white light, a sample goes there, or a laser, 405 laser, and a lid to go over. Here we have the LW LED, which we can use to expose a fluorescent diamond. I don't know if you can see it, almost there. Anyway, it's fluorescing there. Put it over that diamond, and if we look at the spectrum, there we have it, showing the 415 line, which I shouldn't be talking about because that's the job of other presenters. And now what we'll do is put a laser on it, 405 nanometer one, on its own there. We see it glowing merrily now. Block out the light, and the intensity or the spectrum is very similar between the two. So the 405 and the UV, LWUV, can provide similar information. But this is with a brightly fluorescing diamond. What happens if we look at a dimmer one? Now I'm going to place a non-fluorescing or very low fluorescing diamond and see what reaction we get there. Same old light over the stone, and you'll see a bit of a glow here, which is most likely from the LW lamp. And now if we turn the PL system on, you'll note there's a clear difference there in the form of this peak. And the wavelength in this instance of that peak is 429. Now if we get that same brightly fluorescent diamond we had before and put it on this system, a red laser, 633 nanometers, you'll notice it doesn't really fluoresce other than red. How are you going to see anything other than that? But that's not fluorescence, that's the laser. And let's have a look at the spectrum of that. And here we find just one peak standing out. And the wavelength of that is a 694, shall we say. Those peaks are known as Raman peaks or Raman lines, and they're characteristic of the material being looked at. In the case of diamond, a particular structure, it only provides one line at a particular energy difference between the laser energy and the peak wavelengths. If we consider those two lines which I showed earlier, the difference in the wavelength in nanometers is quite a bit, 23 versus 59. But if we look at those wavelengths as a wave number, then the differences are very much similar. This is known as the Raman Shift because the shift is pretty well independent of the laser wavelength. But for diamond, it's supposed to be 1331 centimeters. And if we use the right spectrometer, a high resolution one, and this one set to show Raman Shift, there it is at 1331. There are several ways of describing the location of a feature in a spectrum. Most common for gemologists when operating in the UV, Vis, NIR region is to use wavelength in nanometers. However, physicists sometimes prefer to use energy in the form of electron volts. They are proportional to the inverse of the wavelength. Wave numbers, which is the quantity of waves in the centimeter, are also proportional to the inverse of the wavelength and are usually used for mid-infrared spectroscopy. But it seems spectroscopic systems that include a laser as an excitation source are called Raman systems, and are often the resulting spectra are called Raman spectra, but most often they are in fact photoluminescence or PL spectra. These PL spectra always occur at wavelengths longer than the excitation wavelength, and depending on the defect, excitation in the green or red region may be better than the blue. But a blue source at 405 nanometers is common with commercial systems because if emitted by a laser, it can be efficiently injected into an optical fiber, but more importantly, it can reveal the 450 nanometer line associated with natural diamonds. The temperature of a diamond can affect some spectral features, and it's not unusual in the literature to see reference to the temperature that a spectrum has been recorded at. The colder the better, to remove thermal broadening of peaks. Liquid nitrogen is commonly used for low temperature spectra. I've never recorded under such conditions, but I'm about to try. Here's a diamond with the laser beam shining through it to provide a PL spectrum, and as we look at the spectra, the blue is the original, and you can see the red one, which is the live spectrum, slowly getting narrower and taller. I know some people put the gem in a domestic freezer before testing, but with diamond's very low thermal capacity and high thermal conductivity, I doubt it has much effect. I can try with a block of ice on the diamond, but I seem to be having some difficulty holding it still. That's enough on PL and Raman spectroscopy. I'm now going to move on to absorption spectroscopy in the UV, Vis, and near-infrared region. The colour of a diamond arises because of absorptions in the visible part of the spectrum. As with the colours of fluorescence, while the eye can distinguish an overall colour of a diamond, it cannot detect subtle features in the spectrum, for which a spectroscope or a spectrometer system is needed. With both instruments, white light needs to be transmitted through a gem. What is white light? Here are emission spectra of various light sources that to the eye, each seems white. So a key part of absorption spectroscopy is to normalize transmitted light with reference to the source. In effect, to mathematically divide a light signal transmitted through a stone by the direct source signal. Though it's slightly more complicated than that because usually there's a dark signal to correct for. Depending on the optical configuration, this signal is that when either the source light is switched off or when no gem is present. You don't have to do that mathematical computation. This will be done by software programs that produce spectra. But depending on the system, you might have to record the three types of spectra individually, or for the more expensive systems, that'll be done automatically internally and only the sample spectrum needs to be recorded. I have referred to transmission, and some texts do refer to it, and for the layman it is perhaps easy to understand that, for example, green is transmitted, but for scientists, absorbance is the more common term. So how are they related? Then the absorbance is the log of the inverse of the transmission. So low transmission corresponds to a high absorbance. Such presentation is useful where transmissions might be low. For example, the difference between a 2% transmission and a 1% transmission might be hard to see. Whereas in absorbance mode, that little valley in transmission becomes much more prominent. Anyway, that's probably enough on absorption spectroscopy in the visible region. I'd like to now move into further up the spectral range into the infrared, what's called the mid-infrared. And for that, I'm going to have to leave the surroundings and move elsewhere because I don't have that equipment yet. Here I am coming to a university where they have the equipment in the form of spectrometers, FTIR. I'm still waiting for my equipment to arrive, you see. And it's quite interesting, isn't it, this building? It's got some nice aerolons, probably from Boeing, left over. Anyway, let's go inside, see what there is. The lamp source for mid-infrared spectroscopy is a glow bar. It glows much like a toaster element. Nowadays, the whole infrared system can be quite compact, a lot smaller than the model I have here at this university. The detector for this system likes to be cold, so liquid nitrogen is poured into a housing for the detector. What happens in the rest of the system? I'm not going to take it apart, but will try to describe how it works. The mechanical heart of an FTIR spectrometer is a Michelson interferometer. The basic schematic is shown here, where the light source is directed towards a beam splitter, and in our case through a sample. The beam splitter sends a beam along two arms. At the end of each arms are mirrors that direct the light back towards the beam splitter, where the beams recombine. Now, depending on the length of the two arms, the beams will either constructively interfere or destructively interfere, or something in between. Now, by oscillating one of the mirrors back and forth a minute amount, light of a particular wavelength will pass through constructive and destructive states. Now, add lots of different wavelengths, and you can imagine that the signal at the detector would be very messy as the mirror oscillates. This is where Fourier analysis comes in. So what is this Fourier business? Why is it in the name? I don't think it should be there really. After all, it's just the method by which the infrared spectrum is produced. They could just call it an IR spectrum. Anyway, it seems to be popular usage in the field, so we'll stick with it for now. So Fourier was a mathematician, a French mathematician, probably a couple of centuries ago, who was, besides being smart, a bit of an eccentric. He was of the feeling that being warm or hot, in fact, was good for you. So he moved to the south of France, reasonable thing to do in the best of times. And he wasn't content with being warm enough there, so he wrapped himself up like an Egyptian mummy to make himself even hotter. Perhaps that worked because he did contribute a lot to science. What he developed was a mathematical technique that would change, in our application, a time-changing signal from the detector into a wavelength-dependent spectrum. Back to the instrument at hand, the principle of use is much the same as an UV-vis spectrometer. A background signal needs to be recorded first, which for a glow bar produces a spectrum like this. The noisy parts of the spectrum are from absorption by CO2. It is these sorts of absorptions that are responsible for the greenhouse effect and climate change. For a diamond sample, I'm going to use one of these Argyle Violet Blue-Grey diamonds. I was asked to analyze one of these stones a few weeks ago. It was 0.24 of a carat and of Argyle origin. And the price the retailer had on it for the stone was $65,000 Australian dollars. But can you imagine that? The things I could do with that sort of money. I'd be able to buy a new infrared spectrometer. and have enough left over to travel around the world first class. Which would you prefer? Here's a spectrum I showed at the beginning of this webinar, and it's a typical IR one, which I'll just describe a few of the features. First, I see I made a mistake on there because the x-axis is normally in wave number. So that shouldn't be nanometers, it should be cm to the -1. Oops. What's wrong with this pen? Can you read that? I don't think so. cm -1. And you'll notice it goes from a high number to a low number. That's because it's consistent with what we expect. This is actually a lower wavelength and that's a higher wavelength. So some people will present it the other way around, but this is more normal. And there are a few features there. There's this main absorption peaks here. It's just as an absorbance here, which is characteristic of diamond. So they'll all have this peak structure with diamond. And in this area here, known as the one phonon region, this is where nitrogen information absorption seem to happen with A centers, B centers and the like. And whereas over here, this tends to be where some of the hydrogen related peaks appear. Though they do appear elsewhere as well, and amongst some of these areas, boron peaks will appear. But that will be covered in other lectures in this series. So now let's go back to that blue diamond which I was looking at earlier. Here is its infrared spectrum. You notice a huge one phonon area and also some enormous peaks in the hydrogen area. But if we look at these back to the one phonon area, the saturation there, it's not really a saturation, it's the opposite of that, because the absorption is around 3.4, which is equivalent to about 0.04% transmission. At the other end of absorption, we have type 2 diamonds. These show very little absorption in the one phonon region. We have now considered 3, or rather 4, spectroscopic systems. So how do the various systems compare? Well, Raman systems using longer excitation wavelengths are good for determining if a gem is a diamond or not. While a PL system is excellent for revealing many defects that can relate to origins or treatments, but is less effective for non-fluorescing diamonds on account of, say, high concentrations of A centers or a type 2 character. For those diamonds, UV-vis absorption systems can reveal some of the defects, and for colored diamonds can provide information on colored origins. I forgot to mention that depending on the light source, a UV-vis NIR absorption system can extend from short UV wavelengths down as low as 200 nanometers up to near 1000 nanometers. And finally, FTIR systems are excellent for identifying type 2A, type 2B and type 1B diamonds, and for quantifying concentrations of A, B and C centers that can be useful for origin determinations. One of the delights of PL is that it's insensitive to whether a diamond is rough or polished, whether it's loose or mounted, or whether it's large or small. However, for absorption measurements, it's another matter, and different configurations provide different advantages. Many systems rely on transmission through a stone from one side to another. However, if it is mounted, then this configuration will be ineffective. Mind you, in some circumstances with prong settings, light can pass across a girdle. An alternative configuration can deliver and collect light from the same side, either the pavilion side or the table side. Size is not usually a problem with UV-vis spectroscopy, but with infrared and larger sizes, bigger than a few carats, it can be problematic because the absorption is just too high, and depending on the wavelength, the transmitted light may be too weak to be detected. Since we have a few spare minutes, I wanted to briefly tell you about another application of the Michelson interferometer. This has been used in gravity wave detectors, and they can sense the movement, the change in length of one of the arms of a fraction of the diameter of a proton. And with such extreme sensitivity, they've managed to detect the event in which two orbiting black holes spiral together into some cataclysmic event. But of possible interest to some is it is that event where gold is produced. Before that, we used to think it came from supernova, but no, it's that coalescing black holes. Today we've had a look at a few methods that are used to analyze diamonds. We've looked at PL spectra, UV vis NIR absorption spectra, and infrared spectra. More particularly the instruments that are used and some of the methods to actually obtain those spectra. I haven't, of course, gone into the details of what to look for origin and treatments and that sort of thing, but that's the subject of other webinars or lectures. Anyway, I hope you've learned something. You'll notice it's now dark outside, a bit black, and therefore it's my bedtime, and I'll bid you farewell. Okay, goodbye.
Thank you, John, for this interesting presentation and for showing us how warm is in Australia now, so we can suffer who are in the North Hemisphere. And this is the reason why in the last 7 years I went 5 times to Australia teaching in 4 or 5 cities. It's really very relaxed there, and people are very friendly, and I have a lot of good friends in Australia, of course. New Zealand, I was there as well. So encourage you to ask questions because the best part of this having John today is that you can ask him question, I will help. You can ask me if something is I can help with the instruments. And I will ask also one question just to open up, and then I will read more. So what I see, John, in the last 5 years for sure, maybe longer even, together we are doing Mediterranean Gemological conferences since 2015. And as you know, in the first one, it was mostly a standard instrument, but then immediately we moved in Spain with advanced, with the Margi Labs, bringing portable instruments, and we continue in Italy, Montenegro, Cyprus. More and more appraisers, more and more jewelers. I know I'm distributing the instrument in Canada. I have one pawnbroker, one jeweler, one laboratory bought these instruments that are not very cheap, but they are $5,000 to $10,000, $15,000. So what do you see? Is it coming time with the more advancing in synthetics, become more clean, VVS, lab-grown diamonds, or even gemstones become difficult to identify sometimes with the standards? But do you think that eventually gemologist needs to replace microscope, good microscope, with a good portable advanced instrument? What is your prediction? Or
well, certainly that's one of the objectives that I've been trying to do, is to produce some lower cost instruments so that they are more affordable to the likes of gemologists. Of course, along with that will have to be some training so they know how to use it and how to interpret it, which some people are prepared to do, others not. But yeah, if it's a choice between a $3,000 microscope and a spectrometer, well, of course, I'd be favoring the spectrometer. And perhaps in time, that's one of the effects of technology, is things become cheaper. So indeed, in a few years' time, hopefully everybody who's keen enough will be able to afford one.
yes, because there's a lot of small instruments, $500 to $1,000, that we more call them testers. But though I do receive them to give my opinion on them, and I will cover in my article in our new book about portable instruments. But we don't like so much these testers because they could be misleading, and some of my clients bringing me stones that are obviously diamonds, and testers had moissanite, or they don't know how to use it. And even yesterday, Gary Holloway complained how his stuff in jewelry store cannot use these testers. He's hide away this tester from them. So my goal with this online education and with my workshops, of course, the best thing is to come to workshop and see practically, is to show stones what we can do as a gemologist to train them how to use standard instruments better, and some portable advanced instruments. And one question from Antoinette was about what happened with the Mediterranean conference. And this is exactly what we'll do. July 9 to 11, Antoinette, we were planning in Thessaloniki, Greece. And those who want to come, I think April will finally announce the final program. But for example, in 2 years ago in conference in Montenegro, Major Labs was bringing their instrument and EXA, and now they will bring visible spectrometer. They will bring also infrared. Hopefully, I don't know about Raman. And what we know, John, in last Cyprus, it was very busy. These advanced workshops, like 30, 40 people comes just to look how we'll test diamonds. Correct?
Yes.
Yeah.
Indeed.
And one question in this direction from Abdullah. He's a gemologist working in a lab in Saudi Arabia. If a diamond is irradiated normally of its brown color, then we'll also show one more peak, which 595. I can say this as it's not the topic of this webinar, but we'll talk about this more in April and May when we have a guest on spectroscopy. But I will just tell, yes, if diamond is yellow color or orange, yellow, we should be able to detect this line as additional line evidence of radiation and extra heat. We call it annealing, plus some other lines, 543. Depends on the color. If color turns to be green or blue diamond, then we see what we call GR1 center. That's why it's important, this advanced instrument, because with the regular spectroscope that we John showed today, we are limited to 400 to 700 nanometers, but 741 is beyond that red, going to 741. So it's important to have advanced instruments. So one question from Russia, from Nastasia, is do you provide the liquid nitrogen with your advanced version of spectrometer by Gemetrix?
Well, if I was to provide it, it would evaporate by the time it reached the customer.
I meant, she meant, is it the option with the cell? Do you you demonstrate this today? I know even Miko and Alberto show me it's not standard part of the instrument, but I guess you can try and do it to be better results, correct?
Yeah, I mean, that was the first time I've done it, and I just used a Petri dish to contain the liquid nitrogen. So in principle, anybody with a Petri dish, which I'll be happy to supply, and access to the liquid nitrogen can do that. But I still perhaps want to, just as a matter of interest, complete what I did there of trying to see what the effect of refrigerator ice is. But well, maybe you know, Branko.
Yes, I can tell my experience, because there are a few gemologists in the world beside me who work in 2-3 different labs. I was working in GIA, in Nigel, USA, and mine Canadian Gemological Laboratory, and visited basically, I can say, all major labs. I just didn't go to HRD in Antwerp, but I went to all major labs around the world. So when I started, we use, believe it or not, we did use, we have liquid nitrogen and put metal like box in the liquid nitrogen and quickly put color diamonds on that metal box. And within a few seconds or a minute, observe with the desk model spectrometer. This is what we did in GA in 1995, 98. But of course, we have one person who was dedicated to work on advanced instruments. She was only one, and it was very big and quite slow. We couldn't do 100 diamonds a day at that time, or 50, what is now. So now instruments are much faster. So of course, and I moved to another laboratory, we use liquid nitrogen with another system. Visible spectrometer, it's better to cool it down. And the last 5 years, Thomas Henschwag is very good at making instruments as well, but a different level of instruments. And he'll talk about this in his lectures in June. I'll explain later, if you stay to the end, what lecture we'll do in June and May and April. He makes PL spectrometer and visible spectrometer is a quite large opening. You can really cool it down, even bigger stones. And yes, spectra is much more precise, much more detailed, and we can see defects. It's very important for research, important for stones that are difficult to identify with the standard advanced instrument. There's a portable advanced, there is a research advanced. Yes, John, it's two different animals, two different even price range. We're talking about $10,000s and $100,000s when it comes to research instrument in university that really can find origin of diamonds or look at the color of pink diamonds or green diamonds. Very difficult. This is very advanced level.
Yep, absolutely. Yes, a point I want to make there is sometimes the liquid nitrogen actually, I just showed it sharpening the peaks, but there are instances where you just at room temperature, you see no peak at all. You just see this broad envelope, but then with liquid nitrogen, peaks suddenly start to come out of it in certain instances. So it's a nice thing to have, liquid nitrogen, if you're trying to do serious spectrometry.
Yes, Craig Lynch, appraiser, and also he wrote a book on I think on corundum, on lead glass field, says that we can use dried ice approximately 100 degrees minus. Just to compare, liquid nitrogen, it's minus 290 something. Yes, John, almost 300.
No, almost 200. It's minus 190.
Sorry, 198. Yeah, right, 198. So this is a comment. I know Craig is using advanced instruments. I think he has EXA, what is for me a very important instrument from point of quick detection. I'm using it. You can see now on the back of my laboratory. I'm using it quite regularly. Why? Because when I check every stone first with the peel inspector, like a loop, what is a John instrument, only $300 or jewelry inspector, even better, because you can put a bigger piece of jewelry just to screen the jewelry. This is my steps. And I'll ask this question about John, about he mentioned today mounted jewelry, but then of course I look at the microscope, and if it's something unusual, if I see no fluorescence on long UV, short UV, or short UV is stronger. A lot of melee diamonds now are HPHT grown, and short UV will be stronger. They phosphoresce. Then it's clear. But if they don't fluoresce on the long UV, short UV in all piece of jewelry, something is suspicious. Or I see a little bit short UV stronger, I will always go to EXA and go with the fiber optic and check individual diamonds. And it's very fast, instant spectra. We can see if it's CVD 737, almost always present, or HPHT has different spectral features. We'll talk about this spectra more in next lectures. We cannot cover everything today, but the one question is the direction. I'd like to read all questions just to it's respectful to the people. Guy Bornstein from Israel, who is also a gemologist, and he did a nice workshop in Montenegro, a Gemi Wizard. Can you please give us some guidelines for identifying radiated diamonds which were annealed later to diminish GR1 peak? So what Guy really saying, and we know this who are working in the lab, they would irradiate the diamonds, and then they will put under heat, because when diamond is exposed to heat, it will remove this evidence of irradiation. So we use other ways, Guy, to detect this kind of diamonds, and we'll talk about this. Dusan Simin can talk about this in April 8th, about APHT, what is atmospheric pressure and temperature, and HPHT, high pressure high temperature treatment of diamonds. Some of this information we wanted to publish, what is done in the trade, but some magazines refuse to publish. That's why we like to use this platform, direct webinars, to give you more information, and not all information that we will give you on these live webinars will be on YouTube, because we would like to keep it between us, professionals. But this is what we'll do in next 3 months. So, John, anything more to add about mounted diamonds? I mean, it is a little bit more tricky to check melee diamonds, small diamonds, and mounted diamonds, correct?
It is, but maybe I can make a controversial comment in that, for example, my instrument doesn't really test melee diamonds, but a large customer base for the instrument seems to be appraisers or valuers, as they call them in other parts of the world. And I venture to suggest that whether a melee diamond in your average piece of jewelry is natural or synthetic really makes no difference to its value, or perhaps $20 or something, and therefore testing melee diamonds is not perhaps such a big deal. I said I'd be controversial, so I throw that out.
Yeah, you are. The thing is, I can tell you one thing from my experience. because I'm testing diamonds, I'm doing identification. I have another person doing appraising. We do a lot of rings. Lately, we have a lot of rings that are coming with the center diamond, lab grown, mostly CVD, 2 to 3 carats. HPHT usually smaller. Small diamonds are either HPHT grown or natural. Sometimes they mix them. And one dealer gave me the stone 100% everything natural, but it was like out of whatever, it was almost 100 diamonds. There were 5 or 10 lab grown in mixture of natural, and it was a big deal for him because he's selling product as a whole natural, all, and then even this few amount of melee that are synthetic, if client would know, they would not buy the ring. This is their principle. But of course, there are new generation of clients who doesn't mind, and I have opposite situation that I have a dealer who specializes in lab grown diamonds, and happened 3 or 4 times last month. I see 1, 2, or 3 diamonds in on the side, on the shank, that are natural. How I know? Because using your jewelry pill inspector, I see strong blue fluorescence on long UV, medium strong. Cannot be lab-grown diamonds with the medium strong, very strong blue fluorescence. And of course, I see spectra, I see cape lines, entry center, so it's a natural. So happen both sides, but it's more like a question of selling the right product than the price. I agree with you. Value-wise, is not big difference.
Yeah. Well, okay. It depends what the application is, whether it's a valuer or
yes,
selling to a customer.
I have a question from actually a comment also from Michael Schlamacher from Swarovski, who is our big supporter. He was a speaker at last conference in Cyprus, and hopefully he'll come March 11 on the next webinar, and hopefully you will come. How much is the in spectrum? What I know, both you and me are selling for $3,800 US dollars. Is it correct? Worldwide?
Yep.
Yes.
You will.
Yes. I know you sold a few in Australia, and I sold a few in Canada, and one in Iran, actually. So people are interested in this kind of portable tools. Last week, I had a person who is using X. I did 2 hours direct consulting on spectroscopy. I'm doing this as well for people who are using instruments advanced but don't have enough experience. And he told me what I can do when the diamond is clean and no fluorescence, and what is yes, you have to also try to do spectroscopy, either visible photoluminescence or okay, infrared is much more expensive, but at least this instrument is affordable. It's under $5,000. Okay, so another question from Russia. What % of mistakes in using these tools for diagnostic of original diamonds? As she meant, I mean, if it's the natural diamonds. What is the % of mistakes? John, you can talk about visible, infrared, photoluminescence, and maybe your instrument, or I know my experience from other instruments.
Well, you're probably in a better position to answer that, Branko, because you've actually done tests. But
yes.
In theory, well, I haven't done any tests either, not quantitative ones, but probably the question can be rephrased: which are the tricky ones that can be misidentified? If we're just looking at synthetic versus natural, then probably the type 2s, type 2 naturals come up as a tricky one, for which, well, mind you, you can probably use some of your low cost instruments like cross-polarizing filters, but then you can complicate matters by saying, well, what if the stone's mounted? And then you have to really resort to probably spectra. And but given, if you had to put a figure on that, you could probably, I think it would be safe to say 99% can be reasonably well identified. Would you say, Branko, if you had a selection of several of those bits of equipment?
Yes. What I did the last spring, I was preparing very seriously for my talk in May, last May, to do a talk in Greece, Material Conference on portable instruments. So in lieu of not going there because of COVID, I did a webinar. It was free. It was very well attended. 100 people came. I studied 7 instruments, from Presidium to Jones Instruments, PL and Jewelry Spectre that I'm using, to Gem Pen. Actually, we'll have a lecture on Gem Pen April 1st. It will be free to attend. You'll get the email in March newsletter. and OG machine from OG Israel. I study ID100 as well, because my two clients had OG and ID100, and of course EXA as 7 instruments. So now I'm adding one from DRC, what is a company from India, US, based on fluorescence. I got ARI from Presidium, a new instrument, and Gemological. So I'm adding 3 more instruments this month. So everything will be in my lecture on April 8th. I will talk about this, and maybe John, if you give me my host back, I can talk about this a little bit. And we have also 2 more questions. Of course, I will do this before I talk about what is coming up next. I mean, Shomit saying that yes, John, it's important to have an idea of melee diamonds. I agree. From point of identification, if we have 500 meles, 1000 meles, yeah, it does make a difference. And he also said we found a lot of CVD diamonds that do not fluoresce under these UV fluorescence testers. Can you please shed light on this? I can say from my experience, Shomit, and you're right. Big difference what happened 15 years ago when we published our second edition, 2007. We have very few CVD diamonds and they're fluorescing much more distinct under short UV. Then it's big difference last 5 years ago and last year. I see now stones from certain producers that under long UV and short UV is the same intensity, or some of them under regular UV light. Regular means one that costs $500 or drones $300 to $600. When you excite, all depends how strong is the UV source. When you put a CVD diamond without fluorescence, the G I call none or me, and put a strong PL405 from EXA, they will fluoresce a little bit and they will show some spectra features, but visible, maybe we won't see too much. Still, we published this in a booklet on fluorescence of diamonds. I'll just show you quickly. And actually, it's also in this book, Laboratory Grown Diamonds, about fluorescence. It's still possible to see a difference in fluorescence of diamonds, but it's not the only test, especially because we have now some producers, one of them is Diamond Foundry or the others, who are making diamonds with very little fluorescence. So we need to combine with the cross-polarized filters and microscope in case of standard instruments, and that's why we're teaching these advanced seminars now to a little warm you up for what's coming up in next seminars. So it's necessary to do other tests when diamond do not fluoresce, or definitely if it's a VVS diamond, no fluorescence, it has to be spectroscopy. John, do you agree?
Yes, indeed.
Okay. So one from Marlene Bowman, I think she's from Antwerp. Hi, John. Not sure if there's a time to answer here, but there was a news article about yellow diamonds that were rare purple fluorescence you observe in your lab. I thought it was interesting. Can you elaborate on that? I think this is what you're talking about. This another mine, not Argyle, that has some purple fluorescence. John, do you remember that? Or
well, I do remember it. Yes, very much so. Yes, it was an unfortunate article in some respects because I didn't issue it; the miner did, and the headline suggested it was they're actually purple diamonds, not fluorescing. So I'm glad you read the rest of the article to realize that it's actually the fluorescence that's purple, but it's not as bright as one might like to think, and that's one of the things, as Branko mentioned, that with the jewelry inspector, it's quite a bright light. So with the appropriate exposure, it can be made to look quite strong. But since that article, a few people have said, well, look, they're not that rare. Well, I don't know. I hadn't really seen them before, to see quite a few, a reasonable proportion of the production fluoresce like that. But that's about as much as I can say.
Okay. There's one more question, and then I will a little bit talk about what's coming up. And of course, we can, if something comes in the next 10 minutes, we'll also answer. Catherine is asking, can you clarify the simple cross-polarized test for type 2A diamonds? I don't remember, and I have to view an important diamond in an office with no instrument except what I bring with me.
Okay, I'll just turn
the video. Basically, what is, Catherine, Yes, I don't know if you have a book or not, but on page 134, this is example. I didn't prepare this part, but you can see on the top, this is a natural diamond with typical cross-polarized reaction, very vivid interference colors. In the middle one is a HPHT grown with very little or no birefringence under cross-polarized filters. On the bottom is typical, but it's not always like this, CVD diamond with more columnar. In this case, is not treated stone, but what is nice, that Dusan make nice pictures, and we have, this is one of the best selling little booklets, but then we put it everything in a big booklet to make it easier for you. It's 10 pages of cross-polarized filters in this book, and I want to show you one that is very interesting. Not only you can see here that this is how it looks cross pattern in type 2 diamond. Be careful. This is a CVD diamonds. All of them are HPHT treated, except one in the center, J, that has a pattern parallel to the table that is as grown. It's not such a big deal for price-wise. Again, what John would say, not big deal, but it is big deal from point of people who are buying and selling diamonds. They want to know now, even in labs, separating if CVD diamonds are just grown or they are post-treated. And we will cover this in upcoming lectures. We're starting first from simple and then going from more complicated. So we cannot answer everything today, of course. Thank you for this video and presentation and explaining the principles behind each instrument, what is inside, how they are producing spectra, what's the difference, and what is the main use for gemologists. There's much more, of course, about each instrument and much more to say. That's why we have not one. It's not possible to explain in half an hour. We'll have another 8-9 lectures. So I will encourage people to ask questions at Q&A. Anything about instruments, anything about spectroscopy or fluorescence or spectroscopy fluorescence. And while we're waiting for that, I have a question for you, John, because I'm working in 3 labs, 4 labs now for 25 years. In the beginning, when I started in 95, instruments, I remember in GA, they were quite big and quite slow and took a lot of time to take one spectra, believe it or not, like 20, 30 minutes. And then, of course, they become smaller, faster. And now we see last 5 to 10 years, a lot of new, quite affordable and quite effective instruments to test diamonds. I mean, microscope is the key instrument for, it was, and still it is very important for gemologists, diamond grader or identification. It's maybe a good one with $3,000 to $4,000, maybe more if it's really special one with a camera. What do you think it will happen? Is it the future or present now that eventually gemologist has to replace that instrument with some portable advanced instrument because diamonds are more clean or more difficult to detect with the standard instruments? What do you think?
I think very much so, and that's certainly one of the things I'm trying to do, is to make instruments that are more affordable, because they do give you better information. As you say, if it's hasn't got any distinguishing inclusions, it doesn't have to be diamond, it can be other gems as well, then it can be hard to distinguish, and the spectra is the only way. And unfortunately, they have been expensive, but one of the benefits of technology is with time, they invariably become cheaper. The small spectrometer I showed you is still the most expensive component in some of these systems. You can't get anything under $1,000 US, for example. A lot of them are up at $2,000. But if that price comes down, and then with, and that's what my inspections try to do, is reduce the cost of the other components. As a result of that, there's some limitations, but at least it puts in the hands of the appraiser or gemologist an extra tool that can be a lot more definitive. So yes, hopefully in time it will become part of the standard kit to accompany those other tools, or will be a substitute for a microscope.
Okay. So one question that came quite early when you start presentation, I hope you can remember, what makes the spectrometer you showed at the beginning of the talk, and one from Catherine Wyatt from Melbourne, do these instruments distinguish between synthetic and naturals? I hope she means diamonds, because we're talking about diamonds today. And what extent, which one you would say it's the good one or screening one? Of course, there's always final one between this PL, visible, and infrared, and of course there is photoluminescence.
Yeah. Yes, as you just pointed out, Branko, there's no single instrument other than a diamond view, but we didn't discuss that, which will nail necessarily whether a stone is synthetic and natural. But in 99% of cases, which is what probably most people are happy with, a PL spectrometer system will be effective. The infrared one is used because it can fill in that gap, and a lot of labs do that when they get a diamond in. It's their very first test is to do an infrared spectrum just to see, is it type 2? Because once it's type 2, then that means it's either synthetic or it could be a potentially treated natural. So the infrared on its own isn't sufficient, and that's where you bring in a PL, and you might have to resort, in fact, you will have to resort to the likes of using liquid nitrogen. But generally speaking, and that's why a lot of those automatic machines, whether it be an EXA or the GIA ones and others that are trying to distinguish between synthetic and naturals, will in fact use the PL using that 405 nanometer and detecting the 415 in 3.
I'll just add that GA ID100 is not final instrument. It's a screening instrument that will basically refer.
Okay.
They're saying 2-3%, I think maybe even 5%, because diamonds with unusual fluorescence, who doesn't have entry center, which is 415, will probably refer. Even extra refers some natural diamonds. So it is good screening instrument in the range of $5,000 to $10,000. But in this direction, we have a question from Dusan Simic. What are general differences between spectroscopy systems, instruments for absorption, emission? What cost few thousand and some that cost tens of hundreds of thousands? We're talking about some Renishaw system that is over $100,000, or we're talking about something that costs $10,000 that is probably good. EXA now costs close to $10,000.
Yeah.
What do you see the difference?
The main difference will be resolution and or sensitivity, you might say, perhaps the width over what spectral region it goes. Does it go from 200 to 1000, or like my own in the 400 to 760? So that's a light source issue, but a lot of it's probably that diffraction, the spectrometer heart, that sensor. And for example, the more expensive ones might be able to tell you be able to separate two peaks that are only half a nanometer apart, whereas the lower ones, well, they won't. They'll look like one peak. Yes, that'd be, which I mentioned, the sort of degree of automation. To what extent do you have to manually calibrate and correct, or is it just automatically attended to? And I think some of these more expensive ones will have multiple laser systems. For example, PL, they won't just have the one. You can select different wavelengths, and that's when you start spending tens of thousands of dollars.
But just to add also, some of the PL systems, Raman systems, and infrared, as you show in your university, he has an additional microscope to focus on certain part of a diamond or gemstones to look at the specific inclusions or part of the spectrum. You can take different spectra, different part of diamonds, correct? You can take analysis of little micro part of diamond.
That's true. Yes. Yes. Once you start putting a microscope on it, then you can start looking at specific inclusions or whatever. And and also some of them will do mapping as well.
You're right.
Program
and could be even fluorescence. They can even measure the spectra of fluorescence while decaying or phosphorescing. A lot of things could happen with the good spectrometers. Yeah, I mean, still to do research and to publish some really detailed articles on cause of color or defects, you need the really high-end spectrometers. But you're specifically focusing on the more simple instruments and for gemologists and for appraisers. In this direction, I have Gina from New Zealand, who is our big fan. I think she didn't miss any webinar. Hello, New Zealand. And a question for John, what is the ideal instrument haven't yet developed that you would like to create? If you can tell, or you have idea, maybe you just have idea, or I know Dusan has many ideas and he is very strong in making instruments, but he'll talk about this in April in his talk.
I think probably the most useful one, but unfortunately is very expensive at the moment, and if I could find a way of making it cheaper, I would. Don't worry, I'm working on it. Is a diamond view, having a very short wavelength, deep UV system, and be able to see the growth structure of a diamond. That can be really very definitive. But unfortunately, those systems, I think they're about $30,000 or more. Is that correct?
Yes,
Frank?
yes. Right now, Diamond View, I would just, because of the next book, we are mentioning the different instruments. It's around $35,000 US. What is good about Diamond View, what is really strong short UV light, but a lower wavelength, is that you can see the growth of diamond structure. And in case the diamond is completely clean, or other spectroscopy sometimes doesn't see definite answers, it's one of the very good instruments to complement spectroscopy. Okay, yes, that would be very good if you can make affordable one, but I guess it's not so easy. So in this direction, we also have a question: the difference between point and bulk photoluminescence. A bulk, I guess to explain, means for the whole diamond, or point to focus on. What is the important identification process for diamonds, I guess?
Yeah, I think for diamonds, there's probably very little benefit in any point, unless you've got one that's a diamond that's half natural and half synthetic. But generally speaking, if you're looking at just a point in the diamond, and there are difficulties in only looking at a point, you have to start going into more complicated confocal microscope systems and the like. That's more of a research tool that might be looking at the history, growth of a diamond. But for gemologists, where you're just interested in if it's natural or synthetic, and assuming it's all the same, then there's no benefit of a point. But maybe the question is, what is the difference between that? Well, I've just addressed the importance, but yes, point can look at a specific spot in the diamond, but that's more of a research tool, I'd say.
Okay, one question in the chat from Sarah Olsen, or I don't see the last name, is if a diamond has been HTHP treated or synthesized, does it always show up refer like a type 2A? It's Richie. So it's mean, I guess it's not clear what do you mean refer. I guess refer by the instrument who are referring. There is a lot of black box instruments who are just referring, don't identify it. Dusan and me, the principle, we don't like such instruments because it's not definite. But is for those who want to invest a few $100, $1,000, they're referring, a lot of them. So John, you want to make a comment on this about referring instrument that are HPHT treated, the natural, I guess, or synthesized by us, I mean by people, or lab grown, I guess.
Yes.
She meant black box things. So I can kind of start to answer, or you want to start first? It's up to you.
Well, I suppose the question is, does it always show up as refer? Yes, if it's an HPH treated colorless diamond, it will be a type 2, and therefore come up as refer if the machine is based on, which I didn't touch because it's not really an advanced method, but UV transmission, which is what a lot of the screening ones are. And there's a shortcoming with that, as I found recently, where someone had a parcel of natural diamonds, and they're definitely natural, but about 20 of them came up as refer, and that's because they had a nitrogen state which transmitted the ultraviolet. So they can be a bit confusing in some instances. But you wanted to say something, Ranko?
No, it's the same thing. In some way, I will answer that question and one that Catherine Wyatt asked. So it's a similar question. Is it appropriate to ask what instruments you have in your lab, Branko? Yeah, it's not a secret. Of course, I wish I have another $100,000, $150,000 extra to play with. I would get something more, but right now I have around 5, 6, 7 these screening instruments. Why? Because I don't use all of them, but I do test them as a part of the process of testing instruments on the market. When I was in Australia, actually, if you remember, many of you asked me in Brisbane or Melbourne, oh, what do you think about Presidium? What do you think about this one, that one? So this is a lot of these black boxes, screening instruments. They all have limitations because they will pass natural diamonds and they will refer type 2A diamonds who are all CVD and HPHT type 2A. So beside that, of course, I have a visible spectrometer from 400 to 1000 nanometers. I have a Nicolette DES model infrared spectrometer that is necessary for diamonds, but also for gems, jade, and other stones. And I do use EXA a lot. You can even see it maybe in the back. It's my really big tool because why? Because it's the fastest way for somebody who will see a lot of jewelry, and I see a lot of jewelry because we do also test and appraise jewelry. I have appraiser. It's a point system that you can quickly touch the diamond and see the spectra live. Difference than ID100 because you're just referring. Of course, this is referring on first level, but you can see the live spectra. And if you know what the spectra means, you can separate natural diamond. Even you can see what aggregation or what type of defects has, or is it CVD with 737 absorption, or HPHT grown with some absorption in nickel lines or pattern. This is why I'm using X a lot. I do have a little instruments like Presidium and Gem Pen is also good. Of course, I use a Jones instrument and also selling them a lot in North America. Jewelry inspector, peel inspector. It's a first good screening instrument, fluorescence, but it's not final all the time. It has to be a combination of 2-3 instruments. Fluorescence, microscopy, and spectroscopy is my answer. In that direction, I think, John, you can read the question from Gary Holloway, our friend from Melbourne, who is waiting for second and third generation simple for sale stuff and decisive instruments. Have John's device that require a gemologist. So how long he has to wait for that? For the simple instrument that his staff can use, so he doesn't have to be to supervise them and identify the diamond. So
yeah, well, that's a matter of cost, I suppose. That's not my agenda at the moment because but that's what the black boxes try to do. So they're the simple instruments and they pay a bit more. So the EXA is another example of one that's simple enough for a staff to use, just point and there's the answer. I don't have that on my agenda at the moment because I'm not a programmer, but if the market demands, I might move in that direction. Yeah. So there's another question there, by the way.
Yes, I can ask you one of my questions, and also have another question there. So you showed today mostly instruments and loose diamonds, and of course they're important, and like GL Lab grade only loose diamonds, but in reality, like my laboratory, we see loose and mounted because more mounted than loose. What you will do, or what advanced instruments, or what your instruments, or what you see on the market for mounted stones? EXA, as I mentioned, is good, but the other point system for mounted, like you have fluorescence, bulk fluorescence is good for mounting, of course, because you can see fluorescence even if it's a bezel setting. But what do you talk about? What you can say about mounted identification compared to loose?
It's only a bit much harder because a lot of the systems rely on getting light. If we go away from the fluorescence one, which, as you say, that's easy. But if you're talking about infrared or UV vis absorption, it's often very hard to get the light through the stone. And if I can make a plug, and I'll be answering somebody's question there who says, who makes a spectrometry show at the beginning of the talk? Well, I do, or Geometrics does. And one of the features of it is I wanted it so that it could be used on mounted stones, and so you can put a mounted diamond on the window and get an absorption spectrum.
Mm-hmm.
So and there's also other issues with rough diamonds as well. So those are three conditions which most systems have some either limitation or strength of. There's melee diamonds, mounted ones, and rough ones, and also size comes into as well. Like with the infrared, after a few carats, it can be very difficult to get a decent signal through the stone.
Yeah, what I noticed, and we could do a lot of small stones. Some small diamonds fluoresce differently than larger stones. They have more, not melee has more yellow or orange yellow fluorescence. This is make more difficult for these black boxes to screen, because they will refer them. And I have dealers here who say, why is so much referrals? They say only 5%, 10, 15, because they don't like this orange yellow fluorescence, because it's not typical, showing typical 415 lines, and they're referring everything what it doesn't show 415 lines. So this is a limitation of some testing melee. But it has to be a combination of microscopy and spectroscopy and fluorescence. So one more question about what is the most efficient laser excitation for diamonds, in your opinion? I guess the main lasers from UV to red, but which one for diamonds is the most effective?
If you had to choose one, I would be suggesting 405, and that's the one that EXA uses. That's what I do, because 415 nanometer, the N3 center, is such a key one for detecting natural. You need a wavelength below that. So 405 is readily available. You can go lower than that. 380 would work as well, but 405 is well, you can buy lasers quite cheaply at that wavelength. That's part of the reason. And you can detect a lot of the other defects, even up at 700 at that wavelength, even though a green laser might be more effective, but at least the blue 405 is more versatile in my view.
Yeah. If you come back to webinars in April, May, and June, you will be whoever likes lasers will be fascinating with the different lasers Thomas Henschwag using and make their own instruments, and what is a very high resolution of these lasers. But he has to be a lot of course, much more expensive instruments. So, John, if you don't mind to pass me back the host microphone, so we can still ask for some questions. Like, what is a red laser wavelength? I think you mentioned this in your presentation. It's close to 700 or
633.
Yeah, 63, right? This is red laser. Good. I mean, laser always is good to excite the area above the wavelength. So that's why it's important to use different lasers, because if you want to study more area above 600, we'll use red laser. So 405 is good because it's study that UV area that is important for diamond to check 405 line. Yes. For those who don't have a book, this is about book, but most of you in Australia got it. A few of you who didn't, we can always get from us. I'm very proud we sold 1,000 copies in less than 6 months, what is really good achievement for this crisis. So what is happening next? We noticed that these round tables with a few guests are popular from point of a lot of retailers, wholesalers like to listen more about value of diamonds, how they market them, how they sell them. So March 11, we have Rob Bates as a moderator, Dan Scott from Lab Grown Diamond Magazine, a panelist, Gary Holloway from Holloway Diamonds Australia will be also there, and Michael Schlammegder from Swarovski. It's free to attend, the same as March 18. We are asked to host, give a platform to the group from California, SCS Global Services. They're doing very interesting project of sustainable diamonds, and we'll have people from geophysicists to gemologists from GK Lab to the Lab Grown Diamond Council, responsible source networking, and Washington Diamonds will talk about sustainable diamonds. Not only natural, now that trying to track and find a way to certify this kind of lab-grown diamonds as well. And what is coming really for you who wants to know more and expand on this introductory lecture by John Chapman, it's lectures by co-authors of the book. Like we have in April, May, and June. So first one, John finished. Then I'll talk about different portable instruments, what we touched today a little bit, but there are many more. I studied 7 last spring, another 3, 4 last few months. And Dusan Simic will every week will do 1 lecture. Dusan Simic will talk about APHT, atmospheric pressure, and HPHT, high pressure, high temperature of natural and laboratory grown diamonds. I'll put in 1 interesting color diamond lecture. That one is free. Provenance and grading of pink diamonds from 5 continents, because color diamonds is an important part of the diamonds, natural and synthetic. And then we'll have a special guest from Russia. We'll try to do 2 lectures in Russian for Russian-speaking market. Viktor Vince from Novosibirsk, he's with us tonight. He's doing treatments in and growing diamonds in Novosibirsk. I was there 20 years ago, and he did a lot of research. He'll talk about this. In April, we'll do the same in English. We'll have probably somebody to help him translate or moderate, like Elena and Alexis Zarakani. And we'll have in Chinese and English Taijin Lu from NGTC Laboratory, who will talk about what's happening in China, biggest producer of lab-grown diamonds. They're also doing now doublets of natural and synthetic diamond. He will update us on this, and he's one co-author on this chapter for the book. Mikko Astrom from Agile Labs, he and Alberto designed 4 instruments, advanced portable instruments on visible, Raman, EXA, and the infrared. So they will talk about that end of May. And for those who really wants to go dive completely into spectroscopy and understand all defects and different instruments, different way to detect them, what these defects means, I'll recommend May lectures from Alexander Zaitsev, optical spectroscopy, and Thomas Henschwag. He will do in English and French for French-speaking market on testing diamonds by spectroscopy and fluorescence imaging. This is a combination of fluorescence and spectra, something very, very high-tech, and maybe the final answer for all diamonds. And me and Dusan at the end will finish with the study of, I have around 50-55 samples, and Dusan has 50 to 100 samples that we will put together with different instruments and give you our analysis, something very unique. All these webinars won't be on YouTube. It will be small fee, we think, $29 to attend each of them. And those who wants to attend 5 will have, of course, better price, or all of them 8. It goes $149. And of course, the goal is to promote the book, to raise the money for the book. On diamonds, it will be released hopefully August, September this year, and everybody will get some $20-25 off that book. So this is about the planning webinars. For those who like these last 10 webinars, I hope you like next 10. We're moving into advanced spectroscopy and advanced instruments, but also touching on portable one, practical book as well, not only scientific. And those who want to practice, we still hope we will have this conference in Greece. Some of you attended in Cyprus last one, and I think we had a great conference, a lot of workshops, and we have 5 workshops we are planning, and one of them is by these guys, Mikko and Alberto from Agile Labs. This is what they did 2018 in Montenegro. All day they were demonstrating their practical instruments. And this is what you can learn on samples at the workshops from them. And I will do mine as well on gems. We'll go to the mines, ruby mines, and the Svalred mine in Kosovo and North Macedonia. And basically, this is what I want to tell you. Let me now see. I think we have one extra questions, and I will finish with that. I see somebody asked. Yes, Jan Baker. I think we know Jan. John, I found the in-spectrum easy to use, and like that, I can also obtain spectra for color stones as well. Okay, that's more like a comment. That's great. So we have one user of in-spectrum from Australia, I guess. Okay, John. So I think John has to leave very soon. If he's still there, I will say thank you to him and for the lecture. If he's not, I think he might need to go with with his wife, so it's okay. Thank you for coming. Thank you for joining. I hope it was interesting for you. Give me your feedback, how you like it, and we'll repeat tomorrow morning for Europeans and for North America at 7 a.m. Vancouver time to get up early. And please give me feedback on the talks that are coming. And if you want any other special speaker to come as a platform, we can bring many people, even gems. After the summer, we plan to bring some gem experts, not only diamonds, because gemology is about gems and diamonds. But diamonds is such a big topic, and we want to really make a round up that topic as much as we can. It's never-ending story. I know Dusan already has a plans for 5th edition of our book. This is 4th edition. And it's not only about lab-grown diamonds. It's about diamonds who are treated, who are natural, complicated stones, fraudulent replica, all kinds of things happening on the market. Okay, so I think John left, so it's fine. Thank you, everybody, and hope to see you soon at some conference, at some show that will hopefully resume after summer. Cases are going down in Canada. Still, of course, difficult to travel, but I wish to thank you all and for your time, and thank you for good questions. And I want to say a good night from Vancouver, or have a good day in Australia or Russia or wherever you are.